We're back on the Shaper project, which is going to be making some gears. I need a rig to provide an indexing station. That's the main body of the rig, or jig. There's got to be a foot mounted to it, which will raise it off the deck of the Shaper by, I think it's 5 inches. It's a bit of a pikey setup on the forejaw. I've not got a lot of clearance. I've got about just under ½ an inch behind before it collides with this back of this foot. I've got to drill a hole through, and then that's where the spindle will go, which will take the indexing plates. So we've piloted about 1/3 of the way, 2/3 of the way through, and we're just putting a, I don't remember what size drill it is. I'm opening it out anyway. So off we go. Taking it gingerly because I don't want that piece coming out the chuck. So we're up to 15.5 now. And that's through. So that was pretty much trauma free, thankfully. Don't want to start the year with a disaster, do we? Enough of them going on. So these came in my what's in your toolbox from Keith Fenner and peeps around the world. Nice little set of Starrett telescoping gauges, and they're lovely. There's no great wobble on the ends. I mean, they're well used, but in pretty good nick. So we'll do it at the back, which is going to be fun. I don't know whether you can see that. It's not bad, that, is it? 200th of a mil over, so that's a thou oversize at the start. I better go and refer to my drawing and find out what I did, how enthusiastic I was feeling when I did the design. But I think I've got to come out a bit anyway. Got an idea it's 25 mil or something. Bring you back when I'm on. I'm just tickling it out to 7/8 of an inch with a little boring bar. I've actually got a reamer for 7/8, which is of unknown quality, so we shall see how sharp it is. I'm going to leave 5 or 6 thou on and then just ream it to size by hand. I'm guessing that I'm a long way short of the surface feet per minute for this little boring bar on that diameter. But I'm at a limit of what I'm prepared to risk in terms of winging it round. Feels a bit smoother. Well, we're within a thou, so we're ready for reaming it. Yeah, that's ready to go in. The problem I've got is I haven't got enough clearance behind to get the reamer through past the first 1/4 inch, and it's got to go in at least, got to go through 3/4 of an inch to get onto the parallel section of the reamer. So I shall ream it once I've faced this off to make sure that that face is at 90 degrees to that one, because with the best will in the world, setting it up on that, it's within a thou, but for a light skim it won't do any harm. It don't take a minute. Well, it's adequate, it ain't brilliant. Take the burr off the end, and that's the main body of it done. Need to chamfer that, and then tickety boo. So we're just boring the across hole through, which then we're going to open up for the clamp bolt to hold the unit down. All will become clear when it's put together. Well, this is a kind of finishing up short clip. I'm not sure where I'm going to be tagging it on, so bear with us. So if we ignore the discs for the moment, I've got a tailstock which goes with my rotary table, and then I needed an index unit for direct indexing and driving my gears that I'm going to be cutting. So what I elected to do was, instead of doing a single gear at a time, which is how the original design, which I've blatantly copied from, showed by JB from Oz, and I'll put a link below. Nip over to his channel, give him a subscription, and click as many thumbs up on his videos as you can. He makes some change gears for his lathe, which is basically what I'm doing. So what we got is, I'm going to be cutting 2 or 3 or 4 or 5 of these gear blanks. I've got to bore them out, fit them to a mandrel, and then the mandrel will sit in between the point on here and the point on the end of this index unit. So for all intents and purposes, I'm turning between centres. No, only in this case I'm gear cutting between centres. So I've got to make a shaft that goes through here, carries the centre, carries the drive dog, and then the shaft that carries the gears has got to be a locking shaft, so it'll have a thread on one end, and then a location for me to set the drive dog into and lock it so it can't move. On the other end, I'm just going to shuffle that along a bit. On the other end, I've got an index disc, so that will be, for all intents and purposes, a load of concentric hole patterns. One hole for each tooth, I think it is, or tooth hole, tooth gap, I need to check. But I'm making a 135 gear, 135 teeth, 127 teeth, and then, as I say, half a dozen or so others at around about 60. And they're all going to be made out of steel. These are laser cut plate, and they're all for thread cutting on my Oxford lathe. And the idea is to make up some spares which I can then sell on. So you've got an index gear and then an index arrangements which locks the PCD disc, which is a disc with a groove on it. The diameter of that groove is exactly the PCD, the disc of the gears that you're cutting. that is fixed to the shaft, which travels through this head and links up with the gears. So as this PCD disc is rotated, so do all the gears. The index wheel is only pinned to the PCD wheel via the index pin. So as you pull the plunger, index it, drop it in the next hole, what you're actually doing is moving this shaft around to bring the next tooth into position. If you take a look at Marcus's video on it, he's got, I think there's 3 or 4 in there. Take a look at the editor's cut. It's a bit more detailed, shows you a bit more what the setup is. Now Marcus made all his PCD discs and the index discs on I think it was a pantograph he used, and they're all made out of plastic and they're very slick, very efficient. I've elected to make mine out of steel because I've got no means of cutting plastic, and I might end up making quite a few. So the jobs are many. I'm starting on the main head. I bought that for another job which has only been used once, so the issue was making sure that this I can match the centre height with it, and I can. And I think the largest disc I'm doing is 7.5 inches roughly, so I've got 8-inch discs to turn them down. So it's going to be quite a big project for me. Lots of components going in. We're turning the shaft to sit in the block for the indexing rig. So this is the end that is got to be turned down to fit the indexing plate and the PCD wheel. Then there's a collar, and then there's the shaft that fits into the actual holder which we machined on the shaper. So we've got quite a lot to come down. It's 7/8 of an inch it's got to come down to. It took a big lump out of my tool. You see the it's murdered the end of that tool bit. Yeah, it helps if you turn the camera on. The shoulder length isn't critical. The diameter's got to be within 1 thou, but that face is a clamping face, so it's going to have a series of screw holes into it. I want it reasonably right. I heard on a video the other day, it needs to be reasonably adjacent to the dimension we require. I like that. Right. It's a rough arse finish on that, that's for sure. So we've flipped it round. We're trued it up. We were within plus or minus 1/2 thou from there to there, running concentric to the centre. So I've centre drilled this end. I can't get too deep with the centre drill because at the end of this I've got to put a 60-degree taper on the end of this to catch the bar that holds the gears that are going to be cut. So we've got to take it down to I can't remember what the dimension is, about 7/8 of an inch. Bit of a way off yet though. These came in the what's in the box comp, and they're pretty good. Mr. Toya ones, I'm quite happy with these. Not used them before, so like with all measuring stuff, I think you have to get into a comfortable way for you to use them, so you can get a repeatable measure. Anyway, I'm 27.11 and I want 22, so I've got another 5mm to come off yet. So I just checked all the dimensions and we're a little bit short to leave a 60-degree point on the end of it, so I've elected to modify the design, and I've stuck one of those in which is a 60-degree counter sink with like a protective thing, so it's rebaited in before it gets to the 60-degree section there. It's not easy to see on that. Anyway, so that's that bit done. Just got to break the corners there and there. Not sure where I've made the dimensional error, but it's not a critical one. And yeah, I'll have it out of the chuck in a moment. I'll just clean up the end and jobs are good. Right, so moving on swiftly to the next part. That's the dividing plate. I need to drill and tap now the shaft, so that a dividing plate, not necessarily this one, that can be fitted onto there. And then there's another assembly to take an index pin and then the PCD wheel. On the rear end of it there, we need basically a drive dog, for which we have a sketch. So that's what I'm going to make up now. Shouldn't be too difficult. I just need to work out a sequence of operations to do it, but it's, for all intents and purposes, it's 2 pieces of steel clamped around that diameter with a locking grub screw to pick up the drive pin from the other assembly and make sure that there's no side to side movement. I might also add a flat onto this section just to make sure I can lock it in with a grub screw. Right, dig out a bit of steel and away we go. Right, now that was my block of steel. I've drilled the hole out on the lathe. I've modified the design so I can include a M6 grub screw there, 2 locking M6 cap heads, and then the locking point for the dog. So the next job is to split it down the middle and then clean it up, length and width and all the rest of it. Most of that I'll do on the shaper. Yeah, I haven't videoed it because you've seen me drilling holes and you've seen me tapping stuff. I haven't tapped it yet, but that's the next job. Bring it back in a bit. Just cleaning up the outside faces and bringing it down to size now. So this has turned into a video of clips of work that's been done. That's all ready now for tapping the holes through, and then I'm going to do some file work to take off the corners. All I've done is took the burrs off, and then it fits on the end of there. And that's where the drive pin goes. So yeah, we're progressing. Just going to dress it up now, and those will be done. I just want to take the corners off and make it a bit more hand friendly. Not sure whether I'll record. I might set this up as a time lapse. So we've fitted a little brass thrust washer there. Put some lube down it, and that's spinning nicely. And there's no discernible play anywhere. So I'm happy with that. So the next bit of the indexing head, if we use that as a sample of a divided disc, I've got to drill and tap the holes there. We then need some means of linking that to that, which is going to be the driving disc for the pitch circle diameter, and it's that rotation each cycle of the cutting head which develops the involute gear profile. So what I need to do is basically make up an arm which sits on here, has a collar within it that will carry the PCD wheels, and then the arm come up, go over the top here, and then come down the back side on some kind of slot with a plunger, and with that plunger which links the PCD wheel to the index disc. So as the PC wheel is indexed round, it will take that disc with it, and then you take it back to the start, pull the plunger which removes the linkage between the PCD disc and the index disc, rotate one hole, put the plunger back in, just fire it off again. So I haven't got any fag packets, so I like to make do with a scrappy bit of paper. So that's the assembly we're looking at, which you can ignore for all intents and purposes because it's crap. So I'm making up an arm, this kind of profile, somewhere between 6 and 8 mil thick, depending on what I can find. It'll have a boss at the top end with or if you like, a piece of key steel, which will be set into a key slot, which I'll cut on the shaper, and that will enable me to have an arm which will span either side of that and be able to move up and down and be clamped via that central clamping point. And then the 3 holes here will enable me to mount a collar on its other side, and on that collar will sit the PCD discs. Now, one of the things that I'm aware of is the smallest diameter of gear tooth on my my existing lathe is a 20 tooth, and there's no way on earth I'm going to be able to cut a 20 tooth on here, I don't think, not least because the PCD is fractionally bigger than that shaft. I'll just drop a caliper over it and find out. So a 20 tooth gear on my Boxford lathe is near as damn it 32 mil diameter. That's over the top of the teeth, so your PCD is going to be a bit inside that. I'm going to sit and do the maths for it. So it would be very touch and go, but I don't need a 20 tooth because I've got one, and they are, because they're so small, peanuts to buy. So yeah, there's a limitation in terms of the setup for the indexing for very, very low count teeth, but we're not bothered about that at the moment because I think the smallest one we're doing is 34 teeth. Right, I've got to find a piece of steel and mark that up. So we've got a piece of 10 mil thick bright mild steel. It's come out, it came out of a box from the scrapyard of just scrap stuff like this. Saved my bacon lots of times. Yay. So we're just starting to bore this out. I've drilled it out to 21mm. I don't know what I was thinking when I made the shaft, but the shaft measures 0.05 under 21mm, which isn't a dimension, isn't a round dimension anywhere, shape or form. A 21mm hole going over the shaft or bore gives a little bit too much play, so I don't know what I've done. Anyway, I'm going to bore this one to fit. We're a bit tight. I've had to file the corners off to get it round, and the same here, and I've only managed to get 3 jaws to actually grip it. I tried it at an angle and wasn't happy that it was getting any better a grip. So I'm going to bore it out now, tickle it out gently, and then we're off the lathe. So I'm just finishing off the boss, which will fit inside the index arm on this side, and then the PCD discs on the other side, and it will slide over the end of the shaft. So this bit will be Loctited onto the index bit. I've got to clean it up yet and take it down to size so it fits, and then this flange will give me a shoulder to provide a good alignment. Been running a bit hot. Right, so that's going to be the indexing arm. I've slotted that out with a shaper to take a key which will locate the sliding arm with the pin on the end. That chamfer there, that edge there is 30mm diameter. That will be the ID for the pitch circle diameter plates, which will drive the thing to produce the involute gear shape. I've got to then drill that out with 4 holes. This will be Loctited into the piece here, but I want a method of drilling the 4 holes here without having to set up the rotary table each time. So I've made myself a little jig. The idea is that once that's glued in there, I can drill this out, so I've marked it off accurately. That'll give me my 4 holes here. They'll drill through, tap them out M5 through, and then that jig has got a boss there at 30mm diameter, so that'll go into the PCD discs, and I'll be able to spot them through, in which case the holes should then line up. So a lot of messing about, not a great deal of progress. I'm freezing cold. There's actually ice in my teacup here this morning. I knocked the radiator off last night, so bad mistake. We're just waiting for some drill bits to come, because M5's for a tapping drill is 4.2mm, and I haven't got one, so I've just ordered one, or ordered a selection. That's set up then to drill the shaft through each of those holes. It's a bit of a pikey setup, but it's as good as I can get to perpendicular. So that's the mounting collar for the PCD discs. Just got to deburr them. That fits on there, and the M5 passes through that and bolts into that. I'm setting up the shaper again to finish off shaping the index arm. So I've reground the tool. Well, you can see that. I'm just going to hone the edges on this. I think it's an Arkansas stone. I've not used one before, natural. All my chisel sharpening and the likes has all been on diamond stones or whetstones. Just touching it. What I can see is, even though I've walloped it up in the vise, this end's dropped. So we're going to have to make a slight adjustment to the vise. rough the shape out. I'll just do clean it up with a file, and I think that bit's then done.